Um, Tandega, I think Tandega and Neza, we have 10 attendees, right? That are waiting, 11 now. Should we start? Guys, am I audible?
Yeah, I think so.
Yes,
Yeah.
you're very.
Okay, great. Give me a second. Okay, I think we can start. I think Tandega, you can let the attendees in. Are they in already?
Yes, they are in already, Lisa.
Okay, great. Welcome everyone. Greetings to our EXCO, greetings to our attendees, and a special greeting to Dr. Polaji, who is coming all the way from Zambia, Lusaka, to do a presentation with us. I think this is the first time we are having Zambia doing a SONA webinar. Am I correct or incorrect? Neza, have we ever had a speaker from Zambia?
No, I don't think so.
I don't
recall.
Yes, so wow, Dr. Polaji, you are the first Zambian speaker to come and join us, and we're extremely happy and excited to have you speak to us today. So guys, I'm just gonna quickly read Dr. Polaji's resume. Dr. Mesoli Samuel Polaji holds a Bachelor of Masters and PhD in Human Anatomy. His research focuses on the interaction between metals and the central nervous system, exploring the mechanisms underlying metal-induced neurotoxicity. He is particularly interested in the potential of nutraceutical as a therapeutic agent for mitigating neurological damage caused by metal exposure. Through his work, he aims to elucidate the biochemical and molecular pathways involved in metal toxicity and identify effective strategies for broader understanding of environmental neurotoxicology and the development of novel interventions for the central nervous system disorders that are linked with metal exposure. Dr. Polaji is from Eden University in the Department of Clinical Medicine in the School of Medicine and Health Science in Lusaka, Zambia. So, Dr. Polaji, without wasting any time, I'm going to give you the floor to address us. And then after that, I'm going to give a chance to our attendees to ask questions. And while you are even giving us the presentation, should anyone actually feel that they have a burning question and they're going to forget, please feel free to type it on the text box and we're going to read it. And if you want to ask the question using your own words verbally, please feel free. Dr. Polaji will greet us, and then after that, he's going to switch off his video for the sake of making sure that we have stable internet and his internet is not disturbed. Thank you very much. Please go ahead, Dr. Polaji.
Right. Okay, thank you very much. My name is Mr. Samuel Polaji. Based here in Lusaka, Zambia, with University of Eden, School of Medicine and Clinical Science, Human Anatomy units. I really appreciate you for having me here today. I actually think I'm the first person from Zambia who will be presenting at SONA webinar, and I'm glad to be here to share one of the little research we've been able to carry out, the results with you today. Thanks for having me. All right. Thank you very much. I hope I am very audible.
Yes, you are very audible, and we can also see your slides. Please go ahead.
All right. Thank you very much. Okay. This evening I would be presenting on investigating Eugenol as a neuroprotective agent against lead-induced neurotoxicity, which include the implications of lead-induced toxicity, oxidative stress, monoamine levels, DNA integrity, and of course, dopamine receptor expression. Now, just a minute. Okay. Now, generally, we know that lead is a very potent heavy metal contaminant, and lead generally acts on the central nervous system via different mechanisms, and this mechanism include but not limited to oxidative stress. It could also lead to mitochondrial dysfunction, and of course, we have neurotransmitter dysregulation. Lead generally is a dense, naturally occurring metal that even at low concentration, it's not biodegradable, meaning there is no known bacteria or fungi yet that could actually break it down, and hence it could accumulate and of course lead to long-term contamination. One of the reasons why we took interest in this particular topic was the incidence of lead poisoning in Kabwe in Zambia. And this was as a result of a mine which was called Broken Hill Mine, which was known to extract lead and zinc, but they didn't have the proper environmental control protocols. And of course, as you're well aware, any mining town would also have illegal miners, and most of these illegal miners did not know the dangers associated with lead. And as a result of that, this mine actually operated between 1906 to 1994 before it was closed down. And one of the uses of lead is in making of lead acid batteries, radiation shielding, in terms of ammunition for bullets, and then we have cable sheath, and of course the weight balancing using counterweights also. And this led to a very, very serious lead poisoning because of the fact that the environmental control for this mine to operate was lacking, and as a result, it led to a series of issues that had to do with our public health. So generally, we took this a step further because most of the studies here that were carried out were looking at long-term, they looked at what could be the effect in terms of environmental effect, but not really looking at what could actually happen as a result of long-term exposure to lead. And of course, I would also want to quickly mention the sources of lead exposure that are very common. Could have sometimes in jewelries, sometimes we could have them in some old toys, and of course, we said that the high use of lead led to high demand, and as a result, there was a lot of illegal mining. So the statement of research problem that we found was that lead poisoning was actually a significant public issue here in Zambia, particularly in Kabwe, as a result of extensive illegal mining, which had widespread environmental contamination. And this illegal mining resulted in surface soil lead concentration in Kabwe ranging from 139 to 62,142 milligram per kilogram body weight, which per kilogram, sorry, which is one of the highest that was found among the abandoned lead smelters which were found there. And of course, that point was actually one of the highest known lead contaminants in the world right now. And of course, lead is known to induce neurotoxicity via various mechanisms, and we decided to look at eugenol, which is one of the active components which is found in clove oil and has demonstrated neuroprotective properties in other studies that has been carried out. So, and of course, this kind of research is not yet that popular here, and of course, there are, as a result, few data available with regards to ways of mitigating the adverse neurological effect as a result of lead exposure. And of course, our justification of the study was with the fact that we have a very, very high lead concentration within the soil in Kabwe around the mines. There has been several efforts to reduce lead exposure. And of course, we intended to look at effective therapeutic interventions, which helps to counteract the neurotoxic effects of lead, which so far is limited. And of course, eugenol is also known to have antioxidant properties, anti-inflammatory, and of course, neuroprotective properties. So we given this high burden of lead poisoning in Kabwe, these findings would contribute to developing potential therapeutic strategies for individuals affected by lead exposure, and of course, hoping to improve neurological health outcomes in affected population. And the aim was to evaluate the neuroprotective potential of eugenol against lead-induced neurotoxicity by assessing its effect on oxidative stress markers, mitochondrial DNA damage, dopamine transmission, dopaminergic receptor densities, and of course, cognitive function using novel object recognition task in Wistar rats. Specific objectives include to investigate the impact of lead exposure on oxidative stress markers, such as superoxide dismutase, glutathione peroxidase, nitric oxide, and also to assess the effect of eugenol on mitochondrial DNA integrity. We measured that by assessing the levels of 8-hydroxy-2-deoxyguanosine. This serves as a marker for oxidative stress within the mitochondrial DNA. And of course, we also evaluated changes in dopamine neurotransmission. We looked at enzymatic activity of acetylcholinesterase, and of course, effect of eugenol on dopaminergic receptor densities, and of course, cognitive function using novel object recognition task, and also to determine whether eugenol will be able to mitigate lead-induced cognitive deficit. So the materials and method we used was animals were adults, Wistar rats were used for this study, and they were allowed a period of 2 weeks of traumatization where they were exposed to food. They were given free access to food and water, standard rat pellets, and of course clean water, and they were divided into 4 groups, 6 rats per group. And group 1 was throughout the trial for them, they were exposed to standard rat pellets and of course drinking water, which was the control group. And the second group were orally administered 50 milligram per kilogram body weight of lead chloride. And animals in group 3 were administered 150 milligram per kilogram body weight of eugenol. And then animals in group 4 were also orally administered 150 milligram per kilogram body weight of eugenol alongside with lead chloride. And the duration of these studies of the administration was for 40 days, and 24 hours after the last administration, which is on day 41, the rats were humanely euthanized, and they were anesthetized with 70 milligram per kilogram body weight of phenobarbital. And for the biochemical estimation, we all used commercially available SOD kits, GPX kits, nitric oxide kits, and of course 8-OHDG kits, which was used for intramitochondrial accumulation of 8-OHDG, which is employed as a marker of mitochondrial oxidative stress. And also we assayed acetylcholinesterase and dopamine levels with the appropriate ELISA kit, and following the instructions from the manufacturers. And in terms of behavioral assessment, we utilized novel object recognition. In summary, what the novel object recognition is that it tests for cognitive memory in a rat model, where one of the first things you do is that before you start the test, you have to introduce the animals, the rats, to the test environment, so that when you start the test, the rat would not experience any form of stress, which could also jeopardize the results. And then which is actually, that is what we refer to as the habituation phase. And then we also had like a sample phase where we allow the rats to be familiarized with a particular object of the same size, the same texture, and the same color. And then after that, we had like a retention phase where which we could refer to as a rest period, where the animals are allowed for memory consolidation, for based on the objects they've been exposed to. And then after that, when we started the test itself, you introduce the animal to a new object, and then to the, which is the novel object now. And then you now also have one of the old object which they are already familiar with. So the idea about this is that the rats normally should explore the newer object which they are not used to. They should spend more time exploring that newer object, and then getting fascinated by that new object, and which is the novel object in this case. And normally there should be a higher time spent on a novel object, because normally this is a natural behavior among rodents, and it helps survival even when they are in the wild. So at the end of it all, we calculated the discrimination index by subtracting the time spent on the novel object, and then you minus the time spent on the familiar object which they already been exposed to, and then we divided it by the total time, which is the time spent on novel object plus time spent on the familiar object. So the interpretation would be, when you have a high discrimination index, which means greater time has been spent on the novel object. When you have a low discrimination index, it means that lesser time has been spent on the novel, lesser time has been spent on the novel object, which it would show that there's a cognitive deficit in this case. So the data that we obtained were presented as a mean plus or minus standard error of mean. And then we utilized one-way analysis of variance to identify significance differences between group means. And we used Tukey's post hoc tests to assess the significance, and the mean comparison was performed using a paired sample t-test. And when p is less than or equal to 0.01, values were deemed significant, and the result we obtained was presented in form of graphs and of course a table. So, but for this, would stick to graph for easy visualization. So this that we have here is the effect that we have on superoxide dismutase. Superoxide dismutase generally is a very crucial antioxidant enzyme which protects cells from oxidative stress by neutralizing superoxide radicals. And SOD is basically the first line of defense when it comes to oxidative stress. And as we can see that on the group that was administered lead, there is a significant reduction in the activity levels of SOD when you compare to the control. And then the group that was co-administered lead and eugenol would see that the level of SOD when compared to the lead chloride group is significantly higher, and within the Eugenol group is almost the same thing as that of the control group. So from here we could see that lead resulted in reduction in the body defense the body's defense mechanism against oxidative stress, which was increased by eugenol. And then also glutathione peroxidase, which usually also protects cells from oxidative stress and helps in reducing harmful peroxides such as hydrogen peroxide. Though there are different types of GPX, I think we have GPX 1 to 4, and we can see here that also for the group administered lead chloride, there is a significant reduction in the activity level of glutathione peroxidase, and co-administration of eugenol actually resulted in uh, uh, an increase when compared to the control group, as we can see here. And then on the effect of nitric oxide, naturally we know that nitric oxide is very vital in the body. So it serves as a vasodilator in blood vessels, and also plays a very crucial role in neuronal function. That's why we looked at it. And the synthesis of nitric oxide basically is from L-arginine, and it is also important when it comes to enhancing synaptic plasticity, and of course crucial for memory and learning, but at low levels. Hence, at low levels, nitric oxide is neuroprotective, but at high levels, it combines with superoxide radicals to form peroxynitrate, which is a potent antioxidant, a potent oxidant, sorry, and would contribute to oxidative stress in in the rats. So you'd see here that in the group that was administered lead, there was a tremendous or significant increase in the level of lead chloride, and co-administration of eugenol resulted in in a reduced level of nitric oxide, which indicates that some level of neuroprotection is taking place. And the group administered eugenol only actually had a lower level of nitric oxide. And of course, eugenol on 8-OHDG, which we said indicates intra-mitochondrial, indicates oxidative stress to mitochondrial DNA. And one of the reasons why the mitochondrial DNA is of interest here is because of the fact that unlike nuclear DNA, mitochondrial DNA lacks what we call histones, which protect it from oxidative stress, and of course from free radicals generated from oxidative stress, and of course it's in close proximity to the reactive oxygen species, which is being generated within the system. So generally lead is known to bind to sulfhydryl groups, and when this happens, it inhibits the electron transfer chain, hence resulting in leakage of electrons, and then would have increase in superoxide radicals. And of course, like we talked about previously when we said that superoxide radicals reacting with nitric oxide result in peroxynitrate. So this formation of superoxide radicals, which is mediated by oxidative stress to mitochondrial DNA, would result in formation of peroxynitrate, which would also enhance damages to proteins and lipids. So as we can see here that there is high levels of 8-hydroxy guanosine levels in the lead administered group, and then upon co-administration of eugenol, there was a significant reduction. And one thing we can see here with this result so far is that eugenol actually is able to reduce the levels of nitric oxide and 8-OHDG levels, and of course restoring the activities of superoxide dismutase and glutathione peroxidase. So eugenol, from what we're able to find out from literature, was that it induces the synthesis of this antioxidant mechanism via what we call the nuclear factor erythroid 2, which is very, very important when it comes to synthesis of these antioxidant enzymes. And unlike other types of antioxidants like resveratrol or curcumin, which are known to just scavenge free radicals directly, one thing that eugenol is able to do is that it has a dual pathway, in that it's able to enhance both SOD levels and GPX levels. So in this case, it means that curcumin and resveratrol is sort of limited the type of oxidative stress they might be able to counteract, but eugenol, having that dual function, is more potent than the both that I have just mentioned. And in terms of acetylcholinesterase level, acetylcholinesterase is a very, very important enzyme which helps to break down acetylcholine. And when acetylcholinesterase is low, leads to buildup of acetylcholine in the synaptic cleft, and as a result of that, would have overactivation of cholinergic receptors. And when we have this overactivation of cholinergic receptors, these cholinergic receptors basically are stimulated, they stimulate nicotinic and muscarinic cholinergic receptors. And when these receptors are activated, it results in high influx of calcium ions. And when you have a calcium overload in cells generally impair ATP production, and hence would also can result in oxidative stress, excitotoxicity, and even induce apoptosis. And one of the things we'd notice here is that from the previous slide that I'd shown you, where we have protection of the mitochondria by Eugenol, reducing the generation of, preventing the generation of 8-OHDG would also ensure that, as a result of this, it will ensure that the mitochondria is able to produce the right amount of ATP, which is very important for the synthesis of acetylcholinesterase. So in this study, you would notice that the group that was administered orally had reduced level of acetylcholinesterase, and this would translate to increased oxidative stress, enhanced influx of calcium. As a result, you're going to have excitotoxicity, and then we have accumulation of acetylcholine in synaptic cleft, as I've explained. And of course, when we co-administered with Eugenol, there was an increase in acetylcholinesterase level when compared to the lead group. And of course, we can see also the group that received Eugenol only has a very high level of acetylcholinesterase, which is almost same level with that of the control group. And as a result of this, would explain further when we get to the results from the novel object recognition. Here we have effect of Eugenol on dopamine and dopamine receptor density. Generally, we know that dopamine is very, very vital when it comes to motor coordination within the basal ganglia, and also the reward system, and of course memory. And the synthesis of dopamine generally relies on thyroxine hydroxylase, which is important in the synthesis of dopamine and other catecholamines. And one thing that is that our result was also able to unravel, and when we compare with other studies that also looked at lead, was that when you have lead, usually results in faster rate of dopamine breakdown, which is termed as auto-oxidation. And when you have a high rate of dopamine breakdown, it results in formation of quinones, and quinones are generally known to result in damage to neurons. And like I told you previously, that eugenol has a dual effect, which can work upstream and downstream. And when I say upstream, in this case, I mean that it's able to prevent a generation of reactive oxygen species. And when I say downstream, it's able to also restore neurotransmitter function. In other words, repair the damage that is associated with lead. And of course, you would notice that when we had a reduction in dopamine levels, the dopamine receptor, or dopamine-like receptor density, mean receptor density also reduced. And from literature, we discovered that usually when there is low levels of dopamine within a biological system, normally at first there's an increase in dopamine receptor density, But with persistent reduction in dopamine levels as a compensatory mechanism, the system normally reduces the density and, of course, inactivate most of the dopamine-like receptors so that to protect from excitotoxicity, which was what we also discovered here, where we can see that there's reduced dopamine receptor density associated with reduced dopamine levels. And of course, administration of Eugenol was able to increase. And of course, we also have an increase in dopamine receptor density in this case. And the result for the novel object recognition test, when we talk about novel object recognition, generally, novelty generally refers to animals' ability to detect a new stimulus within the environment. And of course, the ability to detect a new stimulus within the environment is essential for survival, whether in the wild, the ability to find food, find mates, and of course, run away from safety. And one thing that is very vital that lead does is that lead, as we have seen from previous results, that lead has the ability to reduce dopamine levels. And one thing that we know that the ventral tegmental area usually sends dopamine to the hippocampus and the prefrontal cortex. And whenever we have dopamine depletion weakens this loop. And this loop is very important and vital for memory consolidation and, of course, retrieval of memory. And we also have that dopamine depletion, especially in important regions like the nucleus accumbens, would result in reduced motivation and, of course, reduced ability to actually recognize a novel activity, or let me say novel object within their environment. And as a result, this would indicate cognitive deficit, which we can see here among the group that was administered lead. We see that the time average memory index is reduced. And if we compare it to that of the group that received Eugenol and lead, we can see that there's an increase. So you see that Eugenol is actually not only able to prevent oxidative stress, but also it's able to actually repair the damage that is caused by exposure to lead. Though one of the things we were not able to do is to actually explore specific brain regions and able to assess levels of dopamine in these different brain regions as a result of fun. By the way, all this was self-funded, and we also intended to use a standard drug, but if we had used that, we would have increased the number of groups, and it's actually something that was expensive to do, so we couldn't do that. So we just had to do with what we could do. And generally, we would see that Eugenol has been, administration of Eugenol has remarkably ameliorated several impacts by normalizing level of nitric oxide, reducing the levels of 8-OHDG, and of course restoring the activities of important and vital antioxidants. And generally, Eugenol has also been known to be able to activate what we call the nuclear factor erythroid 2, which is very important in the synthesis of antioxidant enzymes. And I would say these are some of the references. And like we say in Zambia, Zikomo, which means thank you. That would be the end of my presentation. Thank you very much.
Wow, thank you very much, Dr. Polaji. What an excellent presentation. I think you have just completely raised the standard for the webinars of 2025. And beyond that, you have also raised the standard for Zambians. I don't know, it's going to be difficult to top what the kind of research you have done. I also just enjoyed the way you explained it, the way you bring mechanism to it, and your ability to just bring everything together. Excellent work. I just want to find out if we have any questions. Do we have any questions? We have Richmond. Richmond, please feel free to switch on your microphone, even your camera if you would like, and ask the question. I'm just gonna take my camera out now and just allow Richmond to give us his question.
Okay, please, am I audible?
Yes, you are audible, sir.
Okay, Dr. Bolaji, it's a very nice presentation. I really enjoyed it. Thank you for that. But I have just two questions.
Okay.
My first question is, what informed the choice of dose for Eugenol? Because I realize you use only one dose for Eugenol.
Okay.
So I want to know what informed the choice for the dose that you chose for Eugenol.
Okay.
And then my second question is on the slide that you had the acetylcholinesterase results.
Yes.
If my memory serves me right, there was an increase in the levels of acetylcholinesterase in the treatment groups. Am I right?
Let me just go back there. In the group that, yes, for the Eugenol group and also for the group of lead and Eugenol.
Yes, there was a higher acetylcholinesterase levels in those groups compared to the lead alone group.
Yes. Hello, Mr. Richmond.
I think Mr. Polaji, if Mr. Richmond is not is not able to speak at the moment, you can just answer the first question that he asked.
Okay. So for the first question was about the choice for the dose of Eugenol. And I have done quite some number of research on Eugenol. In fact, that was what I actually did used for my PhD. And one of the things, which of course has been published, and what determined that dose was actually, during my PhD, I actually varied the dose. I had two doses, like a high dose, and I had a high dose, a medium, and a low dose. And the 150 milligram per kilogram body weight, which I chose, was actually where I got the best results. And that was why I decided to also stick to that dosage. So that was what informed the choice for that dosage. And that work was actually published. And then for his last question, where he was talking about acetylcholinesterase, I did not get that question completely, where he was asking about an increase before I lost him there. So when I was explaining, I had explained that when it comes to acetylcholinesterase, whenever you have low levels of acetylcholinesterase, lower levels of acetylcholinesterase would result in accumulation of acetylcholine, which we were able to also do that part, and probably we might have been able to show that levels of acetylcholine, but funds didn't allow us. So basically, that whenever we have low levels of acetylcholinesterase, it would result in higher levels of acetylcholine buildup within the synaptic cleft, and as a result, you're going to have overactivation of cholinergic receptors, and this overactivation of the cholinergic receptors would result in high influx of calcium ion.
Thank you very much, Dr. Bolaji. I don't know if this I don't know if this is adequate for Mr. Richmond. I'm going to give a chance for another attendee to ask a question. Do we have any other question? While we are waiting for someone to ask a question, I have a question on myself.
Okay.
I was looking at Eugenol. I actually didn't know that the name Eugenol, but I googled it now and I realized that it's cloves, right?
Yes, it's present in different plants.
It's
Cloves,
present in different.
Colibacil, Ocimons.
Yes. Yeah, and
Yes.
I know that cloves, maybe this is just South Africans, but I know that a lot of South Africans drink clove water, even for reproductive health. I just want to find out if one wanted to start looking at using Eugenol as a form of neuroprotection. Now, I know that you have the dose that you used for animals, but if you now have to extract this to human needs, or let me just say human subjects, what kind of dose would you recommend? How much of clothes or any other food that contains eugenol would you say should be consumed? Or is it even possible for one to just buy it directly as a supplement with a specific recommended concentration?
All right. Thank you. I wouldn't want to say I would directly recommend a particular dose for humans. As of course, you're that it takes several processes before you could actually extrapolate something to humans. But one thing that I know is that consuming plants that are rich in eugenol has actually been shown to be very, very good. And there was one that we actually did where we actually isolated the eugenol from clove itself, and it actually was very promising. So when it comes to that, I would say maybe the cloves could just be added to tea as some sort. I wouldn't want to recommend a dose per se.
Okay. Okay, you are
Yes.
answering like a true scientist. You do not want to be implicated. Okay.
No.
Okay, I think we have a question. Sorry for the out of subject question. Will be any certificate for the attendance? Okay. Hakem Elazri, unfortunately, no. Our SONA webinars are just stimulating international engagement by just speaking about science, but we don't offer any certificate for attendance. We just give you a thank you. However, if you do want to be mentioned that you've attended this webinar for some other reason, please let us know. Please contact us using our website. Let me just, I don't know, Thandeka, can you please post the link for our website on the chat if possible? Yeah. Also, guys, just a reminder that we have SONA 2025 in Morocco. You still have a chance to register. It would be lovely to see Zambians as the SADC region. We don't have a strong presence in SONA, but I'm very happy that we have such a big attendance today, and just to have Dr. Polaji come and give us a presentation. I really hope I'm going to see all of you on our conference in Morocco. So if we don't have any more questions, I will assume that we don't have any more questions because nobody has raised their hand and there's nothing on the text box. So I'm going to say thank you very much, Dr. Polaji, for an excellent presentation. You really prepared well. You stuck to time. You did everything up to the T, and we are very grateful for that. I want to wish everybody a good rest of the week. And we hope to see you guys on our next webinar, which is going to be hosted either next month in April. I think April is going to be skipped because of SONA, but we are going to have another webinar in May. So please stay tuned. And Thandeka has posted our SONA website link. Please follow it, and you can even register to be a SONA member using this link. Yeah. So thank you, guys. Thank you for attending. Thank you again, Dr. Polaji, and thank you, Thandeka, for hosting us so well. Bye, everyone.
Thank you. Bye.
Thank you.